So this is the video. If you write Neeraj Kaushik SmartPLS, I think YouTube is visible, YouTube video. So
Yes.
just below the video, you will find CSV file used in the file, Excel manual calculation of this and this. So here they are available. So click on the CSV file. I will get to this link, and now I can download this link. So this is open, means anybody can download it. Just below the YouTube videos it's given. Now let me show you the file and we'll talk. I have made a file of 100 sample size. The reason is it can be worked on, people can work it with the trial version also. 4 are the constructs: quality, loyalty, satisfaction, and behavioral intention. And my diagram is something like this. Here, quality lead to satisfaction, and satisfaction lead to loyalty, as well as intention to buy again. And quality also has an effect on this and this. So satisfaction is a mediator of two: quality, satisfaction, loyalty. Quality, satisfaction, and the intention. Two are the dependent variable, one independent variable, one is the mediator. This is the basic building block. Quality got 6 items, loyalty got 5 items, satisfaction got 4, behavioral intention got 6. All are reflective in nature. All constructs, 4 constructs are reflective. So how I will start working on it? NIT Bhopal. So this video where from I have downloaded, its name is 4.2 SmartPLS part 4.2. Just below that the file is given. I will share, you can download it from here also. More than this doing part, understanding part is important. So import data file, it must have been there, demo 100, import. Now very first thing, when you say import, you should pay a little attention here and quickly go through the minimum maximum. Don't be in a rush to click on the import. If it's a Likert scale, ideally you should go for the data collection. You should check, not our data collection, data cleaning part you should do. 5 things are there in the data cleaning. Hope you are aware of that. But quickly go through. Minimum is 1, maximum is 5. If there is any mistake anywhere, we can rectify. No mistake, we can import it. The first thing it will do, it will compute minimum, maximum, mean, median, etc., standard deviation, kurtosis, and last column is the Kramer V Moses p value. Now this is a test for checking the normality. So it means by default it will check the normality. By default, whether you ask it or not, SmartPLS will definitely check the normality. Null hypothesis is your data is normally distributed. So p value greater than 0.05, null hypothesis accepted. In your case, none of the value is greater than 0.05. It means we can say comfortably that none of the data is normally distributed data. None of the data is the normally distributed data. That's one of the reason you can write that. That's why we are using the PLSM. Now come to the create model. Now 3-4 sort of things are there. PLSM is where we will work on all the things. Wherever the regression is there, its actual name should be NCA. Please remember, when the second option says regression, actually its meaning is necessary condition analysis. So whenever we want to go for the necessary condition analysis, we will go for the regression. Third is process. You can make any complicated, any complex diagram. If you have any prior experience of working with the process macro by Professor Hayes, it is the same. So same can be used. And fourth one is the CB-SAM. No need to work on the AMOS now. So though in this workshop you are given 2 days on AMOS also, but the same thing can be done in the SmartPLS software. They have incorporated the functionalities of AMOS. So as of now, I'm starting with the PLSM. Give it a name. Name is I'm giving it as a model. Any name you can give. Now it will get the values on this side. And please see in the AMOS also, the similar things will be there. On the left-hand side panel, you will find all the items. But as against AMOS, it is extremely easy. Here, you can just select the variable. You can select them using the control key like 1 1 1, you can select that one, then press control button and select one by one, or you can just press one, press shift and the sixth. I hope you know that basic window operations of control and shift, how to choose multiple. Send it out. It's a name should be given quality. Yes. By default, it will make reflective construct. By default, it will make reflective construct. You can change the direction of the items. It can be here, or right click on this, align on the left hand side. It will be left, right click, align on the top, or align on the bottom. You can change its directional anywhere. You can change left side. You can change the name quality, but quality is okay. You can change that. Now satisfaction, throw it out. Name is set, right? The next one is the loyalty. So it's extremely easy making the diagram. It takes just 5 minutes or so making the diagram. This is loyalty, and this is the behavioral intention. I drop it here, so it becomes as a behavioral intention. So far I am using the button. This button is called select. On the top panel, this is called select. Now I will use something else. It is called connect. Using the connect, its change color will change to blue. I made this model. So see, it's just a matter of just seconds making the diagram. It's just a matter of seconds. Now please see, a relation between the blue circles will be called as the structural model. And since generally it comes at the inside of at the center of the model, it is also called as the inner model. Its name is also called as the structural model or the inner model. Whereas a circle with its statement, it will be called as the outer model, or it will be called as the measurement model. Here, a circle and the statements, yellow statements, we are concerned about the reliability and the validity, CFA, whereas a circle connection between the blue circles, this will be called the regression analysis or path analysis. Are you okay with the 4 names? 4 names are the measurement model, also called as the CFA, also called as the outer model. The inner part, blue circles, they are connected. It is called as the inner model, also called as the structural model. We are concerned with the path analysis or regression. On the calculate, there are number of options are available. Click on the first one, PLS algorithm. By default, it works on the path. It says type of result standardized. It says standardize everyone. Yeah, go ahead with that. Click. It will run, and these are the results. Now in the result, let me start from the bottom most. It say this is your original data. The Excel data was like this, behavioral intention, etc. Whatever sort of data you have, it will try to convert the data into the alphabetical, rearrange, not convert, rearrange into alphabetical. So behavioral intention, then loyalty, then quality, and then satisfaction. Your data might have been in other format, but it will go the alphabetically. This is the original data. First, it will convert its Z score, standardized value. Now these are the standardized value, and note down all the standardized values are between -3 to 3, and their mean will be 0, and their standard deviation will be 1. Then it says it will find out the correlation of all with all. Behavior intention, all the statement, it will compute the correlation of every item with every item. Remember, this will be used in couple of calculations. The software will do all calculations for you, but if you are interested in finding out how these are done, these things will be utilized later. And now we have, it will compute very fast, it will compute, and it will give me something called the latent variable. This is the score it has computed. How to compute the score? A very complex calculations are there. I have explained that in my channel. Here I have explained, there must be 1-2 video manual calculation. Because in every workshop, out of the 50 people, generally 1-2 people are there who are very tech savvy or mathematics friendly. They say we want to know how these things are done. So probably I have explained it in some video. Manual calculations part. So most of the people are not interested in knowing what are the calculation steps or so, but please check it out. It must be there. Manual calculation steps, video number 35 and video number 36 for formative, and this how they are checked. This is a process of iteration is used. So that I have explained, but not required for us. We can skip part, and this is the correlation. These are the things which will be required. Now, allow me to take for a moment. Just want to show you a couple of things. That do we require this complete software, or only software will be required only for these computations? Because here, if we just understand a little bit about it, probably understanding will be better. Else there is a table, we will refer to the table. So these are the standardized one. Okay. Now, out of all, I am using only, let's say, satisfaction, because that is the smallest one, and I'm removing the others. Okay. This is my construct score. Put a yellow color, and these four are the items. Are you with me so far? Just confirm it once. What I have done, I have run a model. So number one, in the AMOS, when you will work on the AMOS, Professor Dhaval will ask you that, okay, now you go ahead. Where is my this one? Professor Dhaval will ask you first to make the CFA, means all the circles will be connected by the two-sided arrow in AMOS, and then you will make a model. In SmartPLS, there is no CFA, there is a director model. It will automatically compute. Now you can say that I have not connected loyalty and intention. See, there is no arrow. Okay, there is no arrow between the two, but even then you will find SmartPLS will compute relation between the loyalty and this. Even if there is no arrow, it will compute. So what I have done, I'm just trying to show you what is happening at the back end. So give me 10-15 minutes. If you can understand, really fantastic. If not, nothing to lose. We will come to the where the calculations are given directly. So what I have taken the score of it. Where are the score givens? In the final result, here latent variable is there. In that, the first one is the score. I have taken this one, and I have taken the standardized value of items where it is given in the last indicator data. It is given here as the standardized values. So indicator data standardize here. I have taken the value of this and this, and allow me to make a table. So this table will be data analysis. Let me find out the correlation. So this is the correlation of satisfaction with the rest of all. Label in the first row and give the data into the H1. Okay. So this is the correlation. So that you know that I'm not doing any rocket science. I'm just working with the correlation, nothing, something else. Okay. And I can actually remove this because I'm not really interested in their correlation. I'm interested only in this one, first one. So these are removed. Now, these will be called as, their name will be called as factor loading. So what is a factor loading? Factor loading is the coefficient of correlation between a construct and every item. Now, why I am troubling you? Why I'm not showing you directly the result is there? Because last year we had the interviews in NIT Kurukshetra, and all the professors were there from IIMs, IIT or IIMs. And I was surprised. One professor was there from IIM Lucknow, who happened to be a director of just completed a term of NIT Raipur probably. In the interview, he asked such simple question. He was asking the question, what is factor loading? And remember, the people were the assistant professors who had 10 publication in Scopus or 15 publication. And the question was asked, what is factor loading? And the people were replying, sir, when we work on the SmartPLS, we click there, and it comes. You say, yes, that's very true. But what is factor loading? And people could not answer this simple question. Factor loading is simply the coefficient of correlation between a construct and its statement. Have you seen how I've computed? I've computed, this is correlation. I require software for computing this score. This value is already with me. I have the values from the respondent. I can take their Z score. And then I require software only for computing. I computed the score. Now check it out. Where is it given? So it is given here. Check it out where you will find the on the top. Here it's given outer loading. Now check the outer loading satisfaction. Satisfaction 1 is 622. Check my value is 622. Satisfaction 2, where is it? Probably on the bottom. I hope you are able to see my screen. Satisfaction 2, 907860772. 9078662. Are you with me? Do you get what is the meaning of what is factor loading? Factor loading is the coefficient of correlation between a construct and its item. It's called as the factor loading. Now, here comes a point. I told you coefficient of correlation between these two. Look at the diagram. We are here at this point. Forget about rest all. Let me close this. All Alt X is not working. This Alt A, Alt X, and this is Alt C. Okay, this is doing all C. Now check it out. Let me zoom it a little bit more. Someone please confirm my screen is visible, because I can't see you guys.
Yes, sir.
Sorry, saying something?
Your screen is visible, sir.
It's a visible? Okay. Now my point is, come back to our understanding of simple regression. Satisfaction 1 is dependent variable. This is independent variable. And what is 0.622? This is R square. This is R, coefficient of correlation. We have computed the R here. Now, if I just do its square, this cap 2, what it will become? This is R square. This will be called as the R square. And what is the R square? What is the R square called?
Coefficient of determination.
Or the variance explained?
Variance explained, yes.
R square is the variance explained. How much is the common between the two? And if I take its average, this value will be called as AVE, average variance explained. Average variance explained. Tell me, are you with me? Do you understand what is R? What is R square? This is R square, variance explained. So if I just take the average, it will be called as the AVE, average variance explained. It is variance explained. And if I'll subtract it from 1, what it will become? It will become the error term, unexplained part, residual part. You can call it as residual also. This is a residual part, right? Now, what are the various things we'll look for? Number one, the 5 parameters for the convergent validity. Number one, AVE should be greater than 0.5. Yes, we are okay with that. Number two, there is something called CR. It should be greater than 0.7. CR greater than 0.7. What is CR? CR stands for composite reliability. Composite reliability. How to compute the composite reliability? There is a formula. The formula is get the total of all the beta, 3.16. Also get the total of the residual. This is 1.45. And composite reliability is this value. So let me write the formula here. The CR formula is summation lambda whole square. Summation lambda whole square plus summation of the residual. Check this out. Do you understand what I am writing here? Summation lambda. Now this is called as the lambda. This coefficient, what is lambda? Lambda is basically, lambda means factor loading. Lambda is factor loading. The value will be computed by the software. Don't worry about that. Don't panic. Simply see, formula is not a rocket science. What I am doing, I have added all of these, 3.162 square of that. So is equal to this value cap 2 square of that. Okay. Divided by the same value, this value, and plus the error term, sum of the error term. and the ratio of the two, so is equal to this value divided by this value. 0.827, this is the value of CR. How much should be this value? This shed value should be greater than 0.7. Our value is okay. How I computed the value? The value I computed using this formula. The formula is summation lambda, first add and then the total. I hope you remember summation x square is not equal to summation x whole square. This basic thing you remember? If x is equal to 1, 2, 3, 4, x square will be 1, 4, 9 and the 16. Summation x will be 10 and summation x whole square will be 100. And summation x square will be 30. You add this. Summation x square means first do the x square and then sum. And summation x whole square means first add and then the square of that. When you do square and get the sum, this is called as the AVE. When you get the sum and then you get the square and divide it by this. Can somebody answer one question? Why I have done this as the square? This I have done the square, but this is not the square. Why so? Can somebody explain this part? Why residual term I have not used the square? Residual is simple and lambda I have done the square. Why so? Can anybody think of it?
Residual is supposedly an error.
Yes.
So,
Correct.
so we do not want to multiply the error, no?
No. Error itself is computed using the square. Check this out. This was square.
Ah,
And
oh,
this is
okay.
1 minus square. Residual is already in the square term. When we computed this, this was 1 square of the r square. Residual is 1 minus r square. So since it is already in the family of r square, why we will want to compute it once again? But this is lambda we have just added. Hence its square will be required. So 9.99 divided by this. This is composite reliability. Then there is one more method. This is rho, RHO. And the rho value should again be greater than 0.7. Now, calculations of the rho are extremely tricky. It requires mathematical computations. So probably I have done it here. It's extremely, because one of the friends said that one reviewer asked for how to calculate the rho. So we explored how to calculate the rho and correct one. Okay, this was load. So you can find out if anybody is interested. So I will not go for that calculating part. It requires a very lengthy calculations. You can cross check, must be somewhere. Manual calculation of the rho. Should be here. This one, 4.4, manual calculation of the rho. A very lengthy calculations are there. I'm not going for that. And the fourth part will be the Cronbach alpha. Now, I want you to give a just little idea about all the four so that you remember them and understand it in a non-statistical, non-threatening manner. Let's understand, forget about this statistics, etc. Simply, let's say there is a family. This is a family of a single parent family. This is Sharma family. Now, Sharma family got 3 kids. So this is kid number 1, kid number 2, and kid number 3. 3 kids are there. Kid 1, kid 2, kid 3. Now, the kids have their own relationship. You tell me yes or no. The bonding between the kids, this particular thing, understand this is something like alpha, Cronbach alpha. That's why for computing Cronbach alpha, we don't require the construct score. This is the construct. These are the items. The relation between this is called as the Cronbach alpha. Then the relation between the parent and all the kids, this should be good. Okay. So when you ask a parent, which kid you love most? Parents will say, are you stupid? I love all the kids equally. But ask the kids, ask any kid on the planet, whether your parents love you more or your siblings more. And every single kid will say, I don't know why and how I was born in this family. Nobody loves me and they love my siblings more than me. Ask yourself what you used to say in your childhood. So every kid have a complaint. Every child has a complaint that they don't love me and they love my other siblings. Okay. So what we said, what is this relationship? This relationship is R. Okay. How much is the common between the Sharma ji and the first kid? That is the R square common. This is R square. This is R square. So average of all will be called as the AVE, average variance explained. On an average, every parent must love the kid more than 50%. Rest of the 50%, people search for the love in the friends, in the outer company, elsewhere else. So 50%, if you find you love your kids, that's great. That's good. So what is AVE? AVE is the strength of a relation between the construct and on an average the items, a parent and these one. Are you with me so far? Any doubt in the two things? Are you okay? Do you understand what is meant by AVE? What is meant by alpha? Now, whatever you are not able to get the love, etc., in your family, what you will do? You will try to find that love outside the family. So here it will be the error term, maybe your friends, maybe some other cousins, somebody is there who is there to fill in that vacuum. These are called as the residuals. These are called as the residuals. So let me write these residuals. When you take these residuals also into consideration, so what is this? R, R1, R2, R3. So take the summation R whole square divided by summation R whole square plus summation of the residual. When you consider that, it becomes composite reliability. When these friends are also taken into consideration, composite in the family, outside the family, they are also taken. That is composite reliability. So tell me, what is the difference between CR versus alpha versus AVE? Anybody, any volunteer who understand what's the difference between these three terms? What is CR? Anyone want to attempt? What is CR? What is alpha? What is AVE?
Sir, I will. Am I audible, sir? Good evening, sir.
Good evening. Properly audible.
Yes, sir. Sir, I'll make an attempt to this.
Yes.
Sir, composite reliability, wherein we're trying to explain how much we are able to explain the relationship with the overall construct, which is the explained as well as the unexplained one, the
Perfect.
residual.
Perfect.
And
What is
alpha? Sorry, sir.
Alpha?
Alpha is the correlation among the, in this case, the kids, among the items, I must say.
Right. Perfect.
And average variance explained is, uh, um, sir, it would be the deviations on an average between the items and the construct. On an average, we will take the variance and then we'll conduct the average, basically.
Absolutely.
I hope I'm able to explain.
Yes, you are able to explain how
Thank you,
much
sir.
Parent love on an average the kids. The relation between the parent and the kid on an average, okay, will be called AV. Relation between the kids will be called as the alpha. And when you consider the external members also, friends and colleagues and all those, this will be called composite reliability. And the fourth one, rho, is very, very similar to composite reliability. There are some matrix multiplication used. That's why I'm skipping that part. I'm just looking for, can we compute all of them? Can we compute all of them here? Like if I know the relation between the construct and this, I can take the average. square and average AV is done. Okay, AV part is done here, right? If I know the value here, the residual part I can compute. I can compute that this also. Okay, and can I compute the third one also? Let's check this out. CR. Can I check CR here? Cronbach alpha. Can I check here? Let me just cross check. Go to the data. In the data, there is a data analysis. In the data analysis correlation among all of these. Now give the answer not in H1, rather in the M1. So this is the correlation of all the items with each other. Okay, 1, 2. Now satisfaction is no longer required because Cronbach alpha is the relation between the all the items themselves. Note down the formula of Cronbach alpha. So Cronbach alpha formula is given as, so where should I write? So the formula is alpha is equal to K R bar divided by 1 plus K minus 1 into R bar. K means number of items. Number of items are 4. So K is equal to 4 here. Okay. K is equal to 4. What is R bar? R average. Take the average of all of these. Average of all of these numbers. Okay. And what is alpha? Alpha will be K into R bar divided by 1 plus K minus 1, 3 here, into R bar. It comes as 0.867. 0.867, 868 you can say. So alpha is 0.868. Look at the formula. Formula is K. K is the 4 here. Number of items in the construct are 4. It becomes 4 into R bar, 1 plus 3 into R bar. How to find out the R bar? All the constructs, you take the relation of every item in that construct, every item with any other item. All possible pairs we computed, take its average R bar. Formula is K into R bar divided by 1 plus K minus 1 into R bar. And now we can cross check those who say we are getting absolutely nothing. Okay, now you can wake up. The results here after running, you can come to here where it says construct reliability and validity. In the quality criteria, it says construct reliability and the validity. I tried to explain alpha value 0.806. In my case, it was 868. Okay, seems there's a lot of difference. Reliability is 873. That's perfectly okay. And the AV part is 636. So my part was 636. That's perfectly okay. Here it seems that there is some issue. So let me check 4, 3, 7 to know 1, 9 and 1, the 10. The formula is the same. Maybe I have made any mistake anywhere. K R bar 1 plus K minus 1 into R bar. Let me just put a this one also. 0.868. Okay. I will check, but formula is the same. K R bar by divided by this. And this row is 873 used by the matrix multiplication. So 4 parts are there for computing the convergent validity. The convergent validity is computed for every single construct. Convergent validity is computed for every single construct. What are the indicators? These are the indicators, and the indicators are alpha greater than 0.5, CR greater than this, alpha rho greater than this, and Cronbach alpha greater than 0.7. Cronbach alpha greater than 0.7. So this becomes the convergent validity. Now don't forget to write one more, omega greater than 0.7. How to compute omega? You need process macro for that. No, not process macro, my mistake. Let me check it out. Neeraj Kaushik, omega. So part 1, why there is a mistake of omega, what's the problem with the omega? And part 2, I have discussed how to get that macro from Professor Hayes website. A minute. Wow, it will show the complete video. One more video. Okay, so this is the website from Professor Hayes. Omega.zip file is there. So download it and install it. So after installing, you will get it into the SPSS, attach into the SPSS, and next time when you will start in the reliability, you will find the option of Omega also. So here now you get Omega, Alpha, and this. So it can be, this macro can be installed in the SPSS. So you can go ahead with that. So 5 things are there in the convergent validity. Now come to the next part. The next part is, I'm skipping this part. Any doubts to anyone? Please ask. Any doubt? Anyone want to ask anything? Not able to connect? Pooja asked, what is the difference between composite reliability, rho and or rho C? Okay. Rho, Pooja, when we say rho C, it's composite reliability. One interesting fact is, Pooja, please see here, both are called as the composite reliability. One rho A, rho C. So now for the common, because the name is the same, in academics you will find in the papers, rho C is called composite reliability and rho A is simply called rho. So if I say rho, it means 22 this paper was there which reported the what are the problems of Cronbach alpha. More than 60 years, alpha reigned the world. Alpha was supreme everywhere, unquestionable. Only in the 2022, 21 or 22, the paper come, these are the problems with the alpha, and now you should refer the omega. Very recently, the paper you are reading are 19, 18, 17, 2023, 24. It should be there. That's why the editors, they wrote this common methodological mistake paper in East, probably A or A Star Journal. They say always report the McDonald omega along with it. Now onwards, please report that. Priyanka says, while reporting, both have to be shown. Yes, alpha and the omega both have to be shown, and this is in the reflective only. Only in the reflective you need to answer that. So this part we have done. Any questions to anyone? Getting over the head, getting over the top, not getting numbers and numbers. So what you are thinking when you registered for this workshop? What you are thinking? They will tell you the stories of Thirsty Crow and the Lion and the Mouse. When you registered for level 5 workshop, there has to be numbers and formula and this and that. So, but try to remember in a non-statistical manner a Sharmaji family. And now it's the time to meet another family also. There is a Guptaji family also living nearby, and let's say their dynamics. So,
Sir,
yeah, please.
good evening, sir. Am I audible?
Perfectly audible.
Sir, actually, thank you so much. Sir, actually, I want to ask very basic questions. Sir, please show me the diagram. Sir, actually, you have given wonderful example that how much parents love with their kids. So, this we can call it as composite reliability, internal consistency,
Hmm.
right, sir? And and when we see the relationship between parent and kid, there is construct and item. We can call it as AVE,
AV,
variance explained.
correct.
And sir, how much parent love with their kid as compared to their relatives. So this we call it as alpha.
No,
No,
in
acha,
the
okay.
alpha, only kids are there. There is no relative, no parent, nothing.
Mm-hmm.
Only bonding between the kids is called as the Cronbach alpha.
Acha, bonding between the kids. Okay,
Yes,
bonding between the items.
items.
Okay, this is called as alpha.
Cronbach alpha.
Cronbach alpha.
Yes. No
Okay,
construct,
sir.
no error term, nothing, no relative, nothing. Only between bonding between the kids is alpha.
Okay, sir. And how much parent love with their kid? This is composite reliability.
So
Uh,
in this
mhm.
particular case, Mr. Satisfaction loves satisfaction 2 kid most 0.907, followed by 86, followed by this, and don't like much the first kid as relation is only 0.62.
Mm-hmm.
But on an average, it should be 0.5.
Okay.
50% should be there. What will happen if there is any kid who feels my love is only 30% or 40% 0.3, the kid will invariably go away from that family, won't stay in that family. So in other
Okay,
terms,
sir.
we say if this comes very, very low, drop that item, delete that item and run it again.
Okay. Okay.
This was the question asked by Professor somebody. He said my Cronbach alpha was coming less. So what we can do, or AV is coming less, drop the item with the lowest of the beta, and your AVE and the other things will improve.
Yes, sir. Yes, sir. Actually, yesterday I was asking this question, sir.
Ma'am, have you
Okay.
seen these are the calculation part. When I say, for sure I'm making some mistake somewhere, otherwise the values are exactly same. Okay, let me just cross check. My doubt is that it's probably that it has taken, let me take average like this. This value, this value, this value, and this value. Is the average same or different? It's a coming same. And this is again same. For sure, I have done some mistake somewhere. Point is, ma'am, since I am taking a value of the Cronbach alpha, alpha is equal to K into R average divided by 1 plus K minus 1 into R average. So, ma'am, what is happening? See, this value 0.4 or these values, which are very, very low, they are destroying the entire alpha. If any
Yes.
value is extremely less, ma'am, so this average will be less, overall alpha will be less. If you
Okay,
remove
sir.
such item, then alpha will also improve.
Okay, sir. Okay, sir. So can you please go back to the Excel sheet one more time, sir? Excel sheet, sir.
Mhm. I have clicked, it will come in a minute.
And sir, you have mentioned rho and alpha. So alpha means Cronbach alpha, and what is this
Cronbach
rho
alpha.
actually? Huh.
Okay,
And what is this rho?
ma'am, composite reliability.
Reliability. Okay, okay. Now, okay, okay.
It will be called
Composite
as rho C.
okay,
Composite reliability will be called as rho C. So here one more is there, composite reliability, that will be called as rho only.
okay.
So
So
here
we will consider only row C.
both we will consider. Rho C is CR and this is simply called as the rho.
Okay.
Let's check this out in the this SmartPLS output panel. In the SmartPLS output, just check this out. This is quality criteria, and here it comes composite reliability validity. One is, are you able to see the SmartPLS screen, man?
Yes, yes, sir.
Composite reliability bracket row A. This is simply called row. Composite reliability row C. This is called as CR.
Okay.
Row C is called CR. Row A is called row.
Got it, sir. Got it, sir.
Shall we go
So in
ahead now?
convergent validity, we need to report AVE, CR, rho C, and alpha. And one
Five
more
things.
you have
Omega.
mentioned, sir.
Omega.
Omega. Sir, what is omega, sir? Omega?
Omega is an improvement over the Cronbach alpha.
Okay.
You can watch this video, ma'am. Here you can write Neeraj Kaushik omega. So I have actually spoken what is the problem. I have shared that paper and written what is the problem with the alpha. Why 60 years nobody worked on this, and what is the basic problem with the omega alpha? I have discussed, not I, these people have discussed. I shared their paper and explained that.
Okay, sir. Got it, sir.
Shall we go ahead?
Yes, sir. Thank you so much, sir.
Most welcome. Now let's come to this part. Now there is one family. So this is Sharmaji family having the 3 kids. And then there is one more family. This is Guptaji family. And we will make one more family. So let's say this is a Varmaji family. So three families there. So this is Sharmaji, this is Guptaji, and this is Varmaji. And this is Sharmaji 1, Sharmaji 2, Sharmaji 3. Three kids are there. This is Guptaji 1, Guptaji 2, Guptaji 3. And this is Varma 1, Varma 2, Varma 3. Is that okay, ma'am? Three families are there and all are reflective in nature. So the meaning of the reflective is the arrow direction will be from the circle to the box. This is 1. Okay. And let me put the direction of the arrow. I hope my screen is visible and you are with me. For the every single construct, we will compute the convergent validity. In the childhood, have you gone through those lessons, convex mirror, concave lens, etc.? The word converge means when you checked, all are leading to the one single point. Like the, have you done those experiments, sun ray converge on the paper and then the paper will burn? Converge means when I checked by different methods, the same result was coming. Convergent. What is by discriminant? Discriminant validity requires more than one construct. So it is represented by a two-sided arrow. So Sharmaji is connected with the Guptaji also, and Guptaji connected with the Varmaji, and Varmaji connected with this. All are good people. They talk to each other. Now my question is, which relation should be more? Let's add some spice in the story. Mr. Sharma, single parent family with the 3 kids, and Mrs. Gupta, single parent with the 3 kids. Okay. Now, whose relationship should be more? Sharmaji should be more connected with their kids, with his kids, or Sharmaji should be connected more with Mrs. Gupta? For a happy family, what do you foresee? I can't read the chat, so if you can speak up, that will be wonderful. No answers? This is one.
Own
Sorry?
kids, so own kids. So.
And what will happen if more relation is there between Sharmaji and Mrs. Gupta and then less with this? Then what will happen? If Sharmaji decided that my relation with Mrs. Gupta is 0.9, what do you see? What is going to happen then?
They would be a good family.
Actually, they will not be two family. This will be Sharma Gupta family and they will have the 6 kids. Yes or no?
Yes.
They will be,
Yeah.
they will become as the one family. If their correlation is 0.9, then they will become as the Sharma Gupta family and they will have the 6 kids. This is what is called as the second order or the higher order construct. You understand now what is higher order construct? Two constructs, they are so closely connected. So basically we will say here, this one is the, anybody remembers what was the relation between the kids and the family and the parent? What was the indicator we used to speak? Which indicator talked about the relation between the parent and the child? This relation, what we called it? Anyone remember?
AV.
Why I got the feeling that I am taking, in my class there are several Ghazni, short-term memory loss. I just completed and you know, maybe by 4:30 p.m. it's not right to ask questions about statistics by 4:30 p.m. Now, what is AVE? AVE is nothing but it was the actually R square, summation of the R square, average of the R square. Now, how can I compare? My problem is how can I compare the R with the R square? This is the relation between R1, this is the R2, relation between this, relation between this. How can I compare? This is in the square, this is, two methods are there. Either compare AVE should be greater than MSV. What is MSV? Maximum shared variance. What is that? Take the maximum of R1, R2 and the R3. Whosoever is the maximum, take that. This is first method. Earlier people used to work on this method. AVE should be greater than MSV. These days people say, no, you don't take its average, no, its square. You simply take the under root of AVE. Instead, what we can do, under root of AVE is greater than all R. Please tell me, is it one thing or they are different thing? One and the same thing, or are they different things? Since one of them is in square, other is in R, I can see only two methods. The first method is you take the average of it. And then this R, a relation between the parent and the kids should be more with the parent and the rest all of the neighbors. It should be more than that. Or the second method will be either use this method or use the second method. And the second method was keep it as R square and find out the maximum of the three and do the square of that. That is MSV. This one, second one is called as the Forner-Lecker criteria. One and the same thing. Both are the one and the same thing. It is called Forner-Lecker criteria, FLC. FLC, if AVE is greater, it means a parent with its kids got a stronger bonding than the parent with the rest of the neighbors. That's a good one. People are able to understand this is a separate construct, this is a separate construct, all three are the separate construct. That's a wonderful thing. And we will say our discriminant validity hold true. What is the name? Discriminant validity. What is discriminant validity? Ability to distinguish between the various constructs. How to know? The relation between the construct and its items are stronger, and the relation between the different constructs is there, but it is not that high. What if the discriminant validity is violated? What if discriminant validity is violated? The constructs are saying we are very, very closely connected. Please see if they are all independent variable. Please see, can it be the case of higher order construct? Can you think of the higher order construct? Well, that appeals. If not, then you will find there will be some statement which are connected highly with some other statement. And this will be called as the cross-loading. And cross-loading should be removed. But before that, please ask for, do you understand what is meant by the discriminant validity? What is meant by the discriminant validity? A relation of the parent and the kids, a construct with its item should be stronger than the relation between the various constructs. If it holds true, it means all the constructs are separate. Your respondents could understand these are separate constructs. Any doubts, any questions? No question? Okay. So let me write it here. Discriminant validity points. For discriminant validity, we have 3-4 rules. Number one, we refer to the Fornell and the LARCKER, Forner-Lecker criteria. Forner-Lecker criteria says square root of AVE should be greater than all R, all possible R related to that, not means all, not all related to that construct. The second method is HTMT method. Third method is cross-loading. Let me tell you about the STMT, how to compute the STMT, because last year in Delhi University, yeah, please, any questions?
Sir, just I want to ask one thing, very basic kind of thing, that in case we are going for higher order construct, the threshold for discriminant will be different for
Exactly.
lower order and higher order?
Same.
Okay.
Exactly same.
Thank you, sir.
Okay, let's see what is STMT. I'm covering this part because number one, calculations are very easy, not a rocket science. Number two, it was asked last year, 2023, number of tons of interview conducted in Delhi University, and there surprisingly, experts asked what is the formula of STMT, how to compute, as against the people were clueless. People were saying that yes, STMT is given by the software. Let's see how much are the tricky calculations. Let me find out the STMT between any two constructs. So two things I require. Number one, the correlation between all the items. This is the correlation between all the items. So I'm taking it in a new sheet here, and I'm computing for quality and satisfaction. So let me remove the other statements. These I am removing. These I am removing. Oh, sorry. These I have removed. Okay. Now I have left out with all the items of quality. We got a correlation with all the items of satisfaction. So some values are repeating. Probably this is repeating. Quality. This is one construct. Let me put it into this sort of box. Okay, you're not able to see that. Quality to quality. Okay, this is one construct of all the items. Satisfaction to satisfaction, one construct, all the items. And this one is just a repeat. Can you see 0.073273? This is the same. Quality one with satisfaction or satisfaction with the quality. So I'm removing this part. Okay, three portions are there. See the three portions. One is all the items of quality, and actually it is also repeating 69, 753, 12 with 2. So let me remove these also. And let me remove these also. Okay. Quality, all the items of quality are correlated with others. I found their correlation, and I will call their average as monotrait. Monotrait, TRAIT. What is this? This is the MT for the quality. And how to find it? It is the average value of all the correlation coefficient. Find out the monotrait second. MT stands for monotrait. Now MT for the satisfaction is equal to average of all these values. And then we have the heterotrait. Heterotrait is cross. For both of them, it will be the average of all of these values. And what is STMT? It's a ratio of heterotrait to monotrait. Heterotrait divided by square root of first into second. And it comes out, STMT comes out value 0.495. For quality and satisfaction, let me just cross check. It is given here in the construct reliability and the validity. This was the convergent, and just below that is discriminant validity given. For quality and satisfaction, the value is given as 496, and my comes as 496. Please check it out. What is STMT? Is it a rocket science? Let's try to understand that. What is STMT? Heterotrait means cross. Two constructs should have a high correlation or low correlation. This correlation, if ideally, if they are totally disconnected, if I'll say all the values are exactly 0, so what will happen? What will be the overall STMT? 0. Okay. If their correlation is extremely high, something like 0.9, all the values, and these are low, so what will happen? STMT will be very high. So number one, STMT, lower STMT is better. On the top, it's cross. These values, the two correlation between the two constructs should be low. If this is very, very high, what will happen? STMT value will be high. If STMT is high, it means they are not separate. They are one construct. If it's very high correlation, between the two constructs, it should be low, and within the construct, it should be very high. Then STMT will be low. A low value is preferred. And here we will write that STMT, what is the value given by these people? What is the formula here. So STMT should be less than 0.85. And always remember, lower value of STMT is better. So less than 0.85, it is good. In foreigner lacquer, there was no such cutoff. It was simply said that under root AVE should be greater and STMT should be less than 0.85. So STMT, yes, please.
Sir, if you can just explain how HT is calculated, HT and
HT,
the ratio. Yes, please.
just check this out. It's the average of all the correlation of all the item of satisfaction and quality. Every item with every item. So 6 into 4, 24 are there. 24 correlation value, their average is called as the HT, heterotrait. Remember how I started? I
Yes, sir.
started with
Yes,
the
sir.
correlation coefficient of everyone with everyone. I removed this half of the table because this was repeating. I removed this half because this was again the same. Only once value I have taken. All the average of this I have taken, that is called as the monotrait. For quality, all this item, monotrait. For both each other, it is called as the heterotrait. Average of all I have taken.
Okay, sir. And sir, HTMT is the, if you can explain the calculation, I mean, just explain the ratio of that, sir. HTMT ratio.
STMT, basically, it's the ratio of heterotrait divided by monotrait. But the problem is HT is R, MT is also R into R, it becomes R divided by R square. Doesn't match. That's why I put a under root here. You understand the purpose of our under root? If I
Yes,
don't
sir.
put under root, it will be R divided by R square.
Yes, sir. Yes, sir. Yes.
So we have done HT divided by product of the two MT under the root, two monotrait. So HT will be computed for both and monotrait will be computed one by one. So this is construct 1, this is construct 2. Monotrait. And what is monotrait? This is R bar. How to compute R bar? R1 plus R2 plus R3 all divided by N. As many R are there. Just check this out. Here for the satisfaction, there are these much items. So I have just taken for the satisfaction average of this. I have taken the average of this. This is called as the monotrait. Remember, the same monotrait is used for calculating the Cronbach alpha. Let me attempt one more time. For the quality, there are the 6 items. So I will write 6 into R bar divided by 1 plus 5 into this monotrait. And the value is coming 0.87. This is for quality. Let me just cross check here. For Cronbach alpha for quality is 87. My value is 87. Yes. I don't know where I was making the mistake. You understand? MT is used for computing alpha also. MT is used for alpha. Why? Because this R bar, which I am working here, the same is used in the calculation of Cronbach alpha. Cronbach alpha is equal to K R bar divided by 1 plus K minus 1 into R bar. The same is used, MT is used in the STMT calculation as well as in the Cronbach alpha calculation. The same thing. I don't know what mistake I was making earlier, but check it out. I have used this MT, average of all this. What is the formula? 6, because 6 are the values, 6 into this value, 1 plus 5 into the value. It comes 0.87 and cross check for the quality Cronbach alpha is 0.87. Well, the good news is if you understand, really fantastic, I will be very happy. If you say I get nothing, because the moment you start writing numbers, my mind is switched off, tari zameen pe, absolutely not a problem. This is the table you need to report. Cronbach alpha. If these values are more than 0.7 each, this is good. STMT, this value should be less than 0.85. Fornell lacquer criteria. How to read Fornell lacquer criteria? What is 0.723? 723 is the under root of AVE. Shall we cross check? For behavioral intention, AVE value was 0.523. Let me cross check. For I don't want these values. So let me compute their square root. And this comes square root of AVE 723. And now cross check here in the Fornell-Ecker criteria. What is 723? Behavioral intention. It is under root AVE 754 for loyalty. What is quality? 78 here quality, and satisfaction it is 797 798, right? How to read this? What is 504 578? This is the coefficient of correlation between behavioral intention and loyalty. Coefficient of correlation between behavioral intention and loyalty. What the rule says? Under root AVE should be greater than all the R behavioral intention has with the others. I repeat, under root AVE, what this signifies? 0.723. It signifies a relation behavioral intention has with its 6 items on an average. What is the rule? Rule says this value should be greater than R behavioral intention has with all other constructs. If you go with the same guidelines, loyalty 0.754 is the correlation on an average of loyalty with all of its items. What is the rule? This value should be greater than all the 3 correlation loyalty has with others. 2 values are here and third value is here. Loyalty, behavioral intention, loyalty quality, loyalty satisfaction. So what is the rule? The diagonal value should be more than the off diagonal value in that row and column. Listen it once again. The diagonal value should be more than the off diagonal value, not every value, in that row and column where this you are working with this. This is called Fornell-Ecker criteria. The diagonal value should be more than the off diagonal value in that row and column for that construct. And likewise, satisfaction will be compared with this. If these are okay, you say the values are great. In case some value is more, in case this value is higher than the 0.78, if value is 84, quality and the loyalty, answer you will find in the next table, cross-loading. What is cross-loading? Compute coefficient of correlation of all the item with all of the statement. Compute coefficient of correlation of every item with every statement. What the rule says? A kid should have high correlation with own parent as with the other parent, and the parent should have high correlation with kids other than other kids. Here you will find who's the defaulter. If this value is low and this value is high, in case if it is 84, it means behavioral intention is less interested in the on family and more interested in the satisfaction family. So what to do? This behavioral intention need to be removed from that construct and your discriminant validity will improve. Cross-loading will tell. See, this is the same cross-loading which becomes as the outer loading table. If you just remove the others, loyalty, etc., it will become like this. This becomes as the outer loading. So basically the table is that of cross-loading. Cross-loading says correlation of everyone with everyone, all the item with all the constructs. A construct should have high correlation with its own item and low with the other item. Every item should have high correlation with its construct than other construct. Think of the family. Parents should love their children most than neighbor's children, and children should love their parent more than the other's parent. This will be happy family. In case your love is less and others' love is more, you have to remove that item from that construct. Remove that kid from that family. So we have completed the validity reliability part of convergent one. From my side, this portion is done. You can ask question. Discriminant validity.
Good evening, sir.
Just 1 minute, let me repeat. Discriminant validity, first is Fornell-Ecker criteria, second STMT, third is the cross-loading. Convergent, there are the 5. Yeah, now you can ask question.
Good evening, sir.
Good evening.
Sir, actually my mic and chat both were not working, so I couldn't ask questions earlier. I have few of the questions. My
Yeah.
first question is, we always say that residuals have to be normally distributed. So
Yes.
what is the importance of this normal distribution of residuals?
The purpose of normality of residual is to check assumption that there should not be any outlier in your data. This will show the outlier. Now we don't have that much time. I can show you, but probably I have explained it in one of the video. Please watch there. If just see reverse, what if there is a normal distribution is not there? What will happen then? You tell me that. So if it is not normal, means that is very much away from the rest of that. It means that is an outlier. Outlier should not be there in the regression. That's one of the enemy of regression. So normality of residual is just to check that assumption that outlier is there or not, nothing else.
Okay, sir, thank you. Sir, my another question is this: while calculating HT, just one confusion, that do we consider R of satisfaction and satisfaction, different items of satisfaction also among each other, or do we consider satisfaction with quality only?
Yes, cross. Only cross. When only one
Okay.
construct is there, all the items, it is called mono. Mono means one. One construct monotrait, two construct heterotrait.
Okay, thank you, sir.
That's it. Okay.
Sir, can I ask one question?
Yes, please.
Sir,
Dr.
actually, sir, this is very basic question, basic thing, sir. I just want to ask one more time. So you have mentioned that discriminate validity if the relationship between parent and kid is more cordial, and they are also cordial with their friends and neighbors. That means they are happy family, and this we can call it as a discriminate validity.
No. Don't call cordial. Give
Okay.
parent with the kids should be more, relation should be stronger than with the neighbors.
So relationship should be stronger than the
Stronger.
neighbors. Okay. It sorry, sir. It is
At the end of
considered.
the day, Papa should come back to our family. If Papa is
Okay.
staying with the neighbors, it is a big problem.
Okay, sir. So this we can call it as a discriminate validity, sir.
Yes,
Sir,
discriminant validity means your respondent understood this is a separate construct, this is a separate construct. They could understand. When the things mix up, it means discriminant validity is violated.
Okay. And thank you so much, sir. This is really a wonderful example. We will always remember this thing, sir. So this is very simplest way of explaining the concept. So I really appreciate, sir. Sir, actually, cross-loading, sir, is there any threshold value for cross-loading?
Only thing is cross-loading of the item with its construct should be more with that item and other constructs. A kid should love own parent more and the neighbors less. Likewise, parents should love their kids more than neighbor's kid.
Okay.
More
Okay.
and less. A construct relation with the item should be more with the construct and the other items. So quality should have high correlation with the
Please mute. Sorry, sir.
कोई बात नहीं,
Actually,
उन्हें बताओ कि बाकी पार्टिसिपेंट भी बस रोने ही वाले हैं, ये तो रो पड़ेगा।
sorry, मेरी तरफ से नहीं था.
नहीं
Actually,
कोई बात नहीं, वो
yes, sir.
बाकी
Sir, you mean
से
to
यही
say?
आवाज है सबकी, बस रो नहीं पा रहे हैं यहाँ पे साथी। हाँ जी
No, sir, we literally enjoy your session, sir. Actually, you mean to say that that the relationship should be more between construct and its item as compared to the other items of the construct.
Let's check, ma'am. My screen probably is not visible. Let me share it once again.
Sir, can I, in the same context, can I just ask a related question?
Yeah, sure. Just
Let's
give me
say,
1 minute. Give me
yes,
1 minute. Let me explain ma'am's question. Ma'am, behavioral intention with its construct is 6. Others are 2, 1, 2. Good. Behavioral intention 2, 0.7 with its own construct and less with the others. it is good. Behavioral intention with its item 6, 7, 7, 6, 7, 8, but with loyalty it's 0.4, 0.1, 0.2, 0.5, it's good. Right, ma'am?
Yes, sir.
In construct with its item, this should be highest as compared to the construct and the other item, or item and the other constructs.
Okay, sir. Okay, sir. Got it, sir. And if there is,
Love their parent more than the other neighbor's parent, and the parent should love their kids more than the neighbor's kids.
got it, sir. And if we find that any other construct item is
Relation is there,
more,
you need to remove that. You need to remove
okay.
that.
Okay, okay. Fine, sir. Got it, sir. Thank you so much, sir.
Okay, ma'am. Yeah, somebody
Sir,
else.
I
was
have
asking.
one more.
Yes, sir.
Sir, I have one more confusion.
Ma'am, just wait. Boy was asking something. Yes,
Yes.
boy.
Yes, sir. Yes, sir.
Go on.
Sir, my question was in context to what ma'am was asking. Let's say if there is 0.75, I'm just saying hypothetically, if there is 0.75 factor loading in one variable, and the same statement has, let's say, 0.6 factor loading in the another variable. So that would be considered appropriate?
Okay. Gaurav, see,
Yes, sir.
ultimately it comes, you have to compute under root AVE and other stuff,
Yes.
etc.
Yes, sir.
Only
Yes, sir.
if the problem is there, then you have to come back and remove that. If
Right.
problem is there, then 0.6 has to be removed. If 0.6
Right.
is there, but there is no problem in the the calculation, then go ahead, leave it.
Right. And sir, just by chance, let's say by chance, that factor loading comes out to be same. The value comes out to be same in two different constructs. What to do in that case, sir?
Same means under root
Similar
AVE
value.
equal to R.
Sir, I'm talking of factor loading, sir. Let's say the factor loading comes out to be similar value when it comes to be when we are checking cross loadings.
Mhm.
Let's say by any chances, if can it be possible that it comes out to be a same value?
For the two construct, two
Yeah,
items of the same construct.
one item in two different constructs when we are checking the cross loadings.
One item, we do construct, the value is the
Yes, sir.
same.
Yes, sir. Yes, sir.
Can be there, no problem with
So
that.
in that case, which we should consider that in which construct? Ideally.
Okay. Gaurav, when
Yes, sir.
it says quality 1,
Yes, sir.
naturally it should go to the quality. Why it should
Quality.
go to the loyalty? Okay.
Right, sir. Right,
And then
sir.
second thing is, if there is any sort of problem is there, like
Yes, sir.
STMT is higher, formal lacquer is creating, then obviously quality 1 will be on the radar, it will be removed.
It
But
will
if
be
it is
removed.
not
Right.
doing anything, then you go
Yes,
ahead
sir.
with it.
Right, sir. Right, sir. Thank you, sir. Thank you.
So Gaurav,
Sir,
you
I
might
have a
have someone from your neighborhood, absolutely
Yes, sir.
no problem, till you attempt to, spend night in their family, don't come back to your family, then problem will be there. By that, if you come back in the evening, no problem.
Understood, sir.
Hmm.
Thank you, sir.
Yes, ma'am.
Good evening, sir.
Sir, my
Sarita this
problem
side.
was also the same with Gaurav.
Sir, I have a question.
Yeah.
Sarita this side, sir.
Sarita,
So,
yes.
like in my model, I have one variable where there are three sub-dimensions of organizational commitment. So, if I do not take the sub-dimensions like effective, normative, and continuous commitment, so will that be fine if I just run the this PLS SEM for organizational commitment only?
Okay. In that case, ma'am, the sub constructs are not there. You have a construct having the 9 items or something. This is what you
Yes,
are
sir.
saying?
Yes, sir.
Perfectly okay, ma'am. It's your baby. You will tell how you have done the things and rational for the same. Nobody has a problem with that.
Okay. Okay, sir. Thank you
You
so
can
much, sir.
directly go ahead with that.
All right, sir. All right.
Okay. Yeah. Any other questions?
Sir, can I ask one question?
Yes,
Sir,
please.
I asked this in the morning also to ma'am, but I am still getting confused. So I'm asking you again. I have some 65 questions in Likert semantic differential scale, and I ran EFA on this, which came down to 13 factors. Now, out of these 13 factors also, if I try and make I'm trying to write the names for those factors, and I realize that one of the factors has the summation is negative, probably because I had a negative question, and because of that, the correlation is strong negative. Because of that, the total is also negative, and this is happening for 2 factors out of 13.
Right.
Okay, so should I just remove them outright, or
No.
should I, what do I do?
Just do the factor loading minus remove the minus. Because if you do the reverse coding and run again, it will exactly be the same, only sign will be removed. I have done it. You can check it. Just do the reverse coding. After the reverse coding, run this and you will get exactly the same value. It will be placed with the same everything will be same. Only sign will be from minus, it will be plus. So you can just, without looking anything, remove the sign and go ahead with the analysis.
Oh, okay. Okay. But I mean, what do you do in such a case? I mean, if it is not the reverse coding, but
Why
if
you
it
have
is
not
a
done
negative
for the reverse
value.
coding?
Huh?
Before analysis, reverse coding is mandatory, na?
Yes.
Reverse coding
Yes.
must be done.
Yes. Okay. Okay. Sure. Sure.
Sir, I have
And then
one more question.
these factors, which are 13 factors out of 65 questions. So all these 65 questions will come to my model to form those factors, isn't it? So probably the question number 1, 2, 3, 4, 5, 6 together make factor number 1. And then that will come into my PLS model. Am I right?
Yes, you are right.
I was getting confused because of that, and I asked that yesterday, but probably it was a wrong sentence that I asked, and then you
Not at
really
all.
got. Thank you, sir. Thank you so
Not at
much.
all. Yeah, Pallavi ma'am, please go ahead.
Yes, sir, I have one more question, sir. If this is related to HTMT. Sir, actually, if I'm not mistaken, sir, we should consider that if HTMT should be high between two construct, HTMT should be high between two construct.
No, STMT
No.
should be low. Higher value is a problem, lower value is good. Ma'am, on the top, it's the cross loading. On the bottom is the on. For example, I say both are perfectly correlated. So the value will go more than 1. STMT value can be more than 1. More than 1 is disastrous. It means the two constructs are not 2. They are actually 1. Very high correlation. STMT value should be low. Actually, it should be lower than 0.85. Low value is preferred. Ma'am, just assume if two constructs have totally uncorrelated, what will be the STMT?
Totally unrelated. If two constructs are totally unrelated.
Their correlation is 0. What will be STMT? Cross loading divided by the 2 monotrait under root. Cross loading is 0.
Yes, sir. So 0.
Divided by anything is 0, na?
Yes, sir.
So STMT will be 0. Lower value is preferred in STMT. Should be lower than 0.85.
Okay, sir. Got it, sir.
Okay.
So one more thing.
Yes.
Sir, like when we use PLS-SIM, so there are 3 tables we get. One is specific indirect, one is total effect, and one is indirect effect. So for mediation effect, we look the value from the specific indirect table, and
Yes.
for the direct relationship, we check a value from the total effect table. Is it right?
Not total. We take
Okay.
from the path coefficient.
Okay. Okay. The path coefficient, the
Path
first
coefficient
table.
and
Yeah.
specific indirect. Only 2 we see.
Okay.
Rest, Atul will share that in detail.
Okay. Okay. Thank you so much, sir.
Okay.
Sir, can I ask you one question, please?
Priyanka, go ahead, please.
Sir, actually, I'm writing one paper in which I'm making that customer brand relationship I'm taking as a higher order construct, and through the theoretical, analysis, theoretical base which I've taken, that this particular is a multidimensional construct which is being evaluated by different construct. Like some paper are taking to measure this, they are taking brand satisfaction, some are taking brand loyalty, and some are taking brand identification. So what I did, I have referred CBR as higher order and taking the other construct as lower order construct. So is it okay, sir? Please, if you can just let me know.
That you have to write a reasoning for the same, why you have taken, etc. The first, I do not work in this area, so I'm not the right person to comment. Your question is not about statistics. Your question is about a bit more about the model and the theory. So maybe you should ask the relevant person who work in that area.
Okay.
But,
sir, otherwise, sir, I am really thankful because, the way you explain the things, it's the beautiful presentation from my core of art. I'm really, really thankful because so many things which are having some doubt in my mind, it was really clear today. Thank you once again, sir.
Priyanka ma'am, you've seen in the movies, girls say a very particular dialogue in most of the movies. They say, I haven't seen you from that angle. मैंने तुम्हें उस नजर से नहीं देखा था. तो आप सब ने ना स्टैटिस्टिक्स को बहुत ही गंदी नजरों से देखा है. ये है नहीं इतना गंदा. आपने इसको बहुत ही गंदी नजरों से और नफरत भरी निगाहों से देखा है. ये है नहीं इतना गंदा.
सर डर ही बहुत लगता है इसको देख के.
It's just I tell you, you met certain people who convince you that you won't be able to do that, or didn't explain the meaning of the same, just invested the entire energy into multiply, divide, under root, this and that, and you hated this subject. The subject is not that. Tell me one thing, had I discussed anything other than R? We started with, there is a construct score, and construct score I started with finding out the correlation. That was the R. I have done the R square, average is AVE. 1 minus R square we have done, become alpha, the error we have taken become CR. We taken all the 4 items, taken their R, it becomes as Cronbach alpha. We taken 2 construct their R, it becomes STMT and the foreign lacquer. So what new thing I have discussed other than R? It's only R, coefficient of correlation. One thing is there.
Very nicely explained, sir. Very nicely explained.
Thank you.
So
Thank
you
you so
won't
much.
believe, sir, I joined this workshop only because of you, because I've heard it a lot, sir. Actually, the first time I heard your name from Amit Shankar, sir. He was taking the workshop and he is also an amazing teacher. He said he actually mentioned whatever I learned, I only learned because of Neeraj Kaushik, sir. And
Okay.
he kept telling to us, please watch your videos. But sir, I wanted to attend your live workshop, and this is my first workshop. And please do let us know whenever there is any workshop, sir.
Okay, ma'am. We still
We would
have
love
some.
to join your workshop, sir. Thank you so
Okay,
much.
thank you, ma'am. Let me tell you, tomorrow you will meet Atul Shiva. Atul is a fantastic teacher. And then after 2 days, you will meet
Double, sir.
Professor.
So I know both of them,
He is
sir.
again
Yes, sir.
amazing teacher. These are wonderful people, and you will really love their teaching. Let me just conclude. We got some 3-4 minutes for a formative constructs, because that we have skipped. And believe me, formative construct can be done just in 2 minutes only. Number 1, what is meant by reliability? Check this word once again, reliability. When we say reliability has to do something with the repetitive. We were measuring the internal consistency Cronbach alpha by measuring the same construct again and again, right? But here in the formative, we are not measuring same thing again and again. Example, we have taken knowledge of the teacher, communication of the teacher, patience of the teacher, then empathy, etc., and all make the good teacher. So here we are not measuring the same thing again and again. So what is recommended to check the reliability? We have to use something, a technique, its name is called as, redundancy analysis. So a technique is there, redundancy analysis. Redundancy is the repeat. Redundancy is a word from computer, and redundancy means repetition. So what you will do, measure the overall item, whatever your construct is there, it's a multidimensional, right? But now this time measure this construct in a global single item. Global single item. What is meant by the global? Global means overall. Single means one, item means item. So in the questionnaire, like you ask the knowledge, etc., then last question will be overall, how will you rate the teacher ability of this and this? How will you rate about that name of that construct? So means you will ask overall. It resides on one principle. The principle is, in the long term, you don't remember the every minor details, you remember a emotion. Take example. You went for a Goa trip couple of years back, or any destination, any spot you recall, which you went 5 years back or 10 years back. Now, if I'll ask you which train you took, which was the berth, who are the people, what you ate in the dinner at that time, you totally are clueless. You forget most of it. What do you remember? 10 years back, you had a trip, maybe your school trip. All you remember is we had a fun. we enjoyed. For example, this workshop, you will remember after some years, you will forget all these details, but you will remember, yeah, I enjoyed in that workshop, good or bad, something like that. So get the same into the overall. Ask in the one statement, single item, and global means the overall construct. I know it's a multi-dimensional, but overall, what you feel about the teacher. Now, this global single item will become as the this global single item will become as the dependent variable. This will become the DV, and whatever the score you compute from here, this score will become as the IDV. So here we can represent it like this. Arrows will be here. This is my IDV. IDV means this is my formative construct, the formative construct, and take the single item as the dependent. And the R square should be more than 50%. R square should be more than 50%. See, what is meant by redundancy? Redundancy is the repetition. So it means when you work, one is the thorough method, whatever is the method you compute by the score using the SmartPLS. Take that score and single item should be taken as the dependent variable. And R square should be more than 50%. If you are able to explain 50% of that, it means your formative item has the reliability. Okay, this is called redundancy analysis. Repetition. Measure the same thing 2 times. I know we have said we measure the single time, but not the every item. Simply note the overall construct you measure one more time with the overall word. This will be the reliability. Only one point is there, redundancy analysis. The second part comes as the discriminant validity. Now, formative constructs are by default discriminant valid. Formative constructs by default are discriminant valid. So what you can write, you can simply refer to VIF less than 3. It means discriminant validity hold true. VIF, remember it's a multicollinearity. And you told me that formative is nothing but it's a case of multiple regression. It's a case of multiple regression. So there should not be high correlation among these. Now, do you understand the multicollinearity, which is a problem in the regression and in the number of these things, actually is the same thing which is called as the Cronbach alpha. Do you understand this problem? Relationship between the items. In the reflective, we are calling it as the Cronbach alpha, and we are calling it should be good. But the same becomes in the formative, it becomes a problem with the multicollinearity, and the VIF value should be less than 3. If it is more than 3, then any of the construct will automatically be removed. So you can cross check P value should be less than 0.05 for all constructs. If that is the true, what will happen? If VI is greater than 5 or 3 or actually with more than 5, certainly some of them will become non-significant. You have to remove that from your construct. Okay, so this will be the formative. So we can just let me quickly take 1-2 minutes to make a table. The table will be validity, reliability of reflective and the formative. So this one is reliability, and this is validity. No, not reliability, validity. I'm talking about the convergent and discriminant validity, not the reliability. This is the convergent validity, and this is the discriminant validity of reflective. Number 1, Cronbach alpha greater than 0.7, omega greater than 0.7. Number 3, AVE greater than 0.5. Number 4, what is the number 4? Let me. So number 4 is CR greater than 0.7, and number 5 rho RHO greater than 0.7. Discriminant validity HTMT should be greater than 0.85. Number 2, under root of AVE is less than R. And number 3, answers you will find in the cross-loading. What about the formative? For the convergent validity, it's called as the redundancy analysis. So here one thing is very important. When you go for the
Excuse me, sir. Square root of AB should be greater than R, I guess, in discriminant parity.
AV should be greater than R. Absolutely correct. Should be greater than R. Thank you. Redundancy analysis means single global item you must measure at the time of data collection. This is the problem which most of the scholar they forget. Actually, they collect the data and then they go attend any workshop, and then they are told, have you collected the global single item? And if you have not, then that's a problem. One more thing, it doesn't matter whether you are working with the lower order or the higher order construct. Even if you are working with the higher order, the single global item for that higher order construct should also be asked. Please remember that. The rules are the same. All things are the same for the higher order also. Nothing relaxation, no relaxation anywhere. And here, number one, VIF should be less than 3. Up to 5 can be tolerated, but more than 5 is a problem. And second, P value of every item should be greater than 0.05. Here, the term we use, it is called as the factor loading. Reflective, we call the term as the factor loading. Factor loading is the coefficient of correlation between a construct and the item. And here, the same name will become as the factor weight. Coefficient of correlation between the construct and the item. But in the formative, the term becomes factor weight. In the here, the term becomes the factor loading. So this is all from my side. Whatever the contents were given to me, I tried to cover little bit in rush, but it was little bit about statistics also, about this, that also. I have not answered many of the questions because you are in the safe hands. Next amazing resource persons will be there, and you will be able to get all answers. If anything is missed out, I'm sharing my email ID. You are more than happy. I will be more than happy if you ask any question.
Sir, I want to ask one more last question, sir.
Yes,
Sir,
Parag.
for example, sir, actually this actually happened to me because I was not aware, because my constructs were formative, and I was not aware to collect the overall responses of all formative construct. So later I got to know, it was mandatory. So, sir, I just wanted to say, because I believe that many of the researchers might be in the similar condition, and we have already completed the data collection process. So, sir, is there any other option? What can we do? Because we cannot go to those respondents and again collect the overall responses, overall ratings of that particular formative construct. So, is there any next time we will definitely take care of this, but is there any other way to uh, to overcome of this?
This is the question which may be asked to the research scholars at the time of their final PhD viva.
Yes.
Expert is really a learned person. Expert is why you have not done this, why you have not done that, etc., etc. So very politely and smilingly you will say, अच्छा ऐसा भी होता है, अगली बार से करूंगी मैं, ठीक है? Or I will do it in my follow-up study. Since I was not knowing it, I haven't used. Now I will do it next time. No
Okay,
other.
sir. But sir, for example, if someone is in process of sending that paper for publication, तो वहां तो ये नहीं चल पाएगा, sir. And he or she may put lot of efforts. तो फिर तब क्या करेंगे, sir?
Ma'am, what do you want me to answer?
Actually, just because there are a lot of things that we are still required to learn, and this is a continuous process actually. So that's why I'm asking, because उधर तो हम ये बोल देंगे, अच्छा, okay, we were not aware, we will definitely take care from next time onwards. But assume that we were also in the process of publishing that paper for the publication. And if we get to know similar query from the reviewer, so
Only point is, ma'am, In that case, you have to give other citation that see these are the other published paper. They have also not mentioned redundancy. I followed their steps, so I have also not mentioned. That's all.
Okay, sir. Okay, sir. Amazing, sir. Thank you so much, sir. And I actually wanted to ask one more question, but I forgot. Yes, sir. Sir,
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 I have one
this is
question which
related
I
to
had.
just 1 second. This is related to formative. Sir, when we select the overall response, overall rating of one formative construct, so initially we need to check the redundancy analysis individually for each formative construct just to
Yes.
check the reliability. And we
Yes.
will treat that global single item as DV, dependent
For every
variable.
global single item will be measured
Mhm,
for every single formative, whether it is lower order or higher order. Number
mhm,
two, it will be measured on the same scale. If
mhm.
formative is measured on 5 point, it will be also measured on 5. If that is on 7, it will also be 7. Exactly same.
Got it, sir. And sir, is there any threshold value for redundancy analysis?
zero point 0.5 should be more than 0.5. R square should be more than 0.5.
R square should be more than 0.5.
50%.
Okay, sir.
Sir,
Got it, sir. Thank you so much, sir.
Amrita
sir,
ma'am.
That
I
means that
have
it is
one
correct.
question
Amrita ma'am,
which,
just 1 minute. Yes,
sorry.
Palvi ma'am. Please come.
That means it is correct. If R square value is more than 0.5, then it is correct. And we have
Redundancy
successfully
is not.
collected the overall rating of that particular formative construct.
Yes.
Okay, thank you so much, sir.
Okay. Amrita ma'am.
Hello, sir. I forgot to ask last time, while teaching today, you mentioned that whatever pilot you are doing, EFA should have a different data set and CFA should have a different data set.
Yes.
Whereas I did my pilot and I did the EFA with 135 respondents. And now I am in process of collecting some 600 responses. But can I not add the earlier responses to the new one?
Should not be.
Oh.
Should not be added.
And why is that so? Because then I will have to probably do more of data collection because
Absolutely.
it loses some 135 responses then. So
Okay.
why is this not allowed, sort of?
Okay. So for that, I will refer you one paper.
Huh.
Ma'am, in Malaysia, there are some wonderful professor, Hiran Tag and these Ramaiya and etc. So they have written a paper, actually two parts are there. This paper
Okay.
basically talks about, this is the paper, a review of
Okay.
methodological misconception and guidelines. Are you able to see my screen, ma'am?
Yes, I can see
Okay.
it.
So just below that, I have given the link of this video, which of this paper. Probably it's available on the ResearchGate. And
Okay.
in that, it's not a paper. It's just they said all these professors, Mumtaz Ali Menon, Kiran Ting, Ramaiya, Cheek,
Okay.
all are the legends. They say that our scholars ask so many questions. So a question, the answer, and the references they have provided. So they talked about the 3-4 things. EFA, CFA, they talked about the pre-testing, pilot testing. They talked about all such stuff they talked about, and plenty of references are given. Please watch this. This is part one, 2-part video I have made. This entire paper I explained. There they have specifically given so many references. EFA, CFA should not be applied on the same data. You can read that paper in detail.
Cool. Thank you so much, sir.
Most welcome. Yeah. Any
Hello,
other question?
sir.
Yes, ma'am.
I have a question, sir. Fornal-Larker, STMT, and cross-loading all are used to check the discriminant validity.
Validity, right.
So, sir, is there any difference? Like, why we are using these three? Like in all are used for checking the discriminant validity, so there must be some difference in that.
Yes, obviously. Obviously, there's a difference. When you speak up about, okay, somebody shared the screen, probably. Okay. Ma'am, when you check the cross-loading, basically cross-loading and STM, Fornal-Larker criteria are almost the same. Let me just cross-check. No, they are not the same. In the cross-loading, ma'am, we have taken item and the construct, their correlation. In the AV part, the underroot AV, Fornal-Larker criteria, we have taken the correlation of all the constructs only, ma'am. Just cross check. All the construct correlation is there in the Fornal-Larker criteria. While in the cross loading, all the item and the construct, their correlation is taken. Separate dimensions we have taken. And STMT talks about the three, their correlation and the cross correlation. So three different perspectives are there for checking. We check it from the three perspectives.
Okay. So I just want to say that thank you for the session. It was really nice. And just thank you.
Okay.
Sir, I just want to ask one more question. Sir, what is bootstrapping, sir? Bootstrapping.
Bootstrapping is used for the getting the T value, ma'am. Since, see, this Atul will share this thing in detail, ma'am. Actually, the problem is, since you are working on such a small sample, how can you use the Z test? And that too, you said it cannot be normally distributed. But the Z test requires the normally distributed data. Answer to that is the bootstrapping. Atul will explain it in much detail. Priyanka asked a question. You told us that factor affecting, it can be done using already developed CFA directly. Then we have to check reliability, validity, and you have taught us. Yes, Priyanka, it's exactly the same. If you work on the existing scale, existing construct, then do check the reliability and validity of the same. Correct. Any other questions?
Hello, sir.
Ankita?
Sir, I'm Sana.
Okay.
Sir, my question is, if I'm using two mediating variables and I'm checking the impact of individual factors that is affecting decision making, and there are two mediating variables between these two, how will I know if these two variables are working together and then contributing to the decision making, or one is more dominating than the other?
Use the specific indirect effect.
Okay, sir. Okay.
Yeah, now I think maybe my voice is audible, sir. How are you?
Perfectly okay, sir. Perfectly okay.
Yeah. I think thank you so much, sir. And participants, maybe I think we are going over time. Maybe after that also you can contact sir. Maybe we are providing sir mail ID, everything. And this is really, we are grateful to you, sir. We have continuous last 2 days on SmartPLS, AMOS. Maybe our participant, definitely they will get more benefit. And really, you are such a great resource person. Maybe not only for participant, even though us also we have learned something, even though we are also keep on teaching SmartPLS, but certain new things you have highlighted. And really, we are very thank you so much, sir. And you have covered many things like from beginning to like a basic research methodology to at end of the confirmatory factor analysis, and maybe if you are going to dimension reduction and with the exploratory factor analysis, maybe definitely based on your way of teaching style, maybe those who are our almost more than 120 participants, definitely, hopefully, maybe soon they will develop one research paper also based on SmartPLS and AMOS. Really, we are grateful to you, sir. And maybe not only this, it will stop our association, maybe it will continue in future. And soon we'll invite to NIT Bhopal also, maybe in order to we are keep on conducting those workshop. And really, we are grateful to you, sir. Thank you so much. And participants, maybe and free to, maybe we are providing sir mail ID and contact number also. Maybe anytime you can approach and you will get it clarification from sir. Thank you so much, sir. And maybe again after that other process we can contact you. Thank you so much, sir.
Thank you everyone for giving this opportunity. Thank you NIT Bhopal and Professor Amit especially.
Yeah, thank you so much.
Thank you, sir.